Ernan, the fine-tuning of the universe is today one of the hottest intellectual subjects.
Right.
Physicists talk about it, philosophers, theologians. You're kind of all three. So how do you look at the fine-tuning of the universe?
I think it's a unique issue. I would want to argue that the fine-tuning issue is something that has never happened before. And it's not a kind of topic that has ever, in fact, come up before. It's not like the natural theology of the past. But in order to understand that, you have to see what has happened to science, what has happened to cosmology in the last 100 years. Because up until the 1920s, 1930s, the idea that we could reach back to the origins of the universe was simply unthinkable. For Newton, the universe was infinite in time, infinite in space. There was nothing you could say about it. I mean, an infinite universe, an infinite extended in space and time, that's all you could say. That's the end of it. But what happened very unexpectedly was a combination of circumstances, both in terms of observational astronomy, galactic movements, outwards expansion, and theoretical movements, Einstein's general theory of relativity. The two of those came together in the 1930s in the work of people like Lemaitre, for example, to give us what was derisively called the Big Bang. That was intended to be a put-down originally, but the name was kind of stuck. Now, the interesting thing about that is that it was unique for physics to be able to reach back in time in that way, to be able to say something about something that had happened, as they first thought, around 2 billion years ago. Now we would say 14 billion years ago. I mean, reaching back, not only reaching out in space, but reaching back in time. That's incredible. Now, that was unique, of course, in science, but it was also unique in theology, because here for the first time was a hint of a knowledge of how it all began, which is something that earlier religious believers never really thought we could reach out to in terms of our own human powers of reason. So there was a potential from the theological standpoint about this idea to begin with. But then what happened when in fact in the 1960s, in the light of new discoveries of the microwave radiation, the Big Bang theory itself for the first time started to be taken seriously, because up to that point it had been a fairy story for most physicists. As I remember in my own physics department at the University of Notre Dame, for example, it was a source almost of amusement by the physicists. It was one of these stories you tell. But along came the people who worked on microwave radiation, and Penzias and Wilson, and Peebles in the middle of the 1960s. And all of a sudden it was a real theory, because in fact, here was something that had been in fact predicted some years before by some students of Gamow, that in fact there would be a relic radiation from the beginning. If in fact the Big Bang theory was right, there would be a radiation, a relic of that, which would have been, as it were, expanding, cooling off all of the time. And here it was. So there's nothing that will impress a physicist more than an unexpected prediction which is unexpected to begin with, but is then verified. That really carries conviction. But then what happened next was again very unexpected, because in the early 1970s, people like Hawking, for example, began to discuss the fact that the Big Bang itself would have been a quantum event, not just a matter of relativity and so on. But here was an extraordinary concentration of energy, and therefore quantum mechanics should apply to it. But when you applied quantum mechanics, and especially when you looked at the way in which relativity worked into it, it turned out that the energy density that would have been required in order to produce a universe that could be long-lasting was so particular, so specific, that in fact it was almost impossibly detailed. You would have to have it dead right in order to allow elements, heavy elements to form, in order to allow evolution and human beings to exist. In order for all of that to happen, you had to have a long-lived universe. But to get that, you had to have a pretty fine setting at the beginning. So the first sort of argument in the direction of fine-tuning was of that kind. But then a few years later, a different line came in, which has proved to be more long-lasting, which is that a number of physicists looked at the laws of nature themselves and pointed out that the laws of nature, the laws of particularly of the fundamental forces, they're very specific. And it turns out if you alter the relationship between the fundamental forces, between, let's say, gravity and electromagnetic forces, if you alter them even a very small amount, you will not get a life-bearing universe. You'll get a universe that will collapse right away, or a universe that is nothing but hydrogen, which is not very interesting, and not a universe which is nothing but helium, which won't do anything. In order to get a universe of our kind with multiple kinds of elements and long-lasting and so on, there's a lot of requirements to get a life-bearing universe. In order to get that, it turns out that the laws of nature have to be pretty much what they are. Now, at that point, the question was, what do we make of that? Well, there are only 4 possible answers to that, in my view. One answer would be to say, well, this is a matter of luck. I mean, so we're lucky. We're in a chance universe. We're in a universe that might have been very different, but it is this way. So that's a chance result. In other words, you block any further question. Chance means you don't block, you block all further question. Now, scientists don't like blocking. They don't like that sort of response. Chance is not a very happy response from the physicist's point of view. The second possibility, which I think has to be taken seriously, as it turns out, is that the theories themselves are at the growing point. I mean, relativity theory and quantum theory have not yet been unified, and the whole prospect of unification is still, it seems, somewhat far off. And for that reason, one has to tread very warily here, because it's at least possible, at least one can't rule this out easily, that the further developments that will bring together these are 2 fundamental physical theories, which have not yet been unified, that the fundamental theory that might lie ahead might possibly make sense of this apparent coincidence that we happen to have the right kind of universe in which life itself can develop.